So let's invite our next speaker. I would say our next speaker is Ivan Zvieriev, and the one we are glad to have in our studio. Hello.
Hello. Hi, guys.
Hello,
Hello.
Ivan.
How you doing? How you feel about
I'm
Java
fine.
conference?
I'm continuing Grace tradition to come sick to the conference.
I do
So
hope it won't be tradition.
if I will be coughing from time to time, I'm sorry for that. But what to do?
So
It's this period, you know.
I definitely think we need to move our conference somewhere from November. I think that's the
Definitely.
problem.
You know,
It was a
when
long
kids
ride.
when kids are bringing like now I have one kid in kindergarten, another in school, and they are like bringing different set of viruses. Now it's even more tricky.
Okay, guys. So for all our audience, please be safe. I don't know. Wear warm socks. Prepare some tea with lemon. So yeah, please be safe. It's November, so a lot of viruses around. So Ivan, can you share with us, maybe in some words, what your talk would be about?
I guess I will do that in the beginning, but in
Oh,
general, every time I speak about something, it's about low-level Java in this or that regard. So today it will be more about high-frequency trading, low-latency financial systems, and compilers. Um, Initially, I wanted to build something around compilers, but then I understood that maybe it will be interesting to hear like compilers is only part of it. So yes.
okay. Great to hear. So a small reminder to our audience that we are monitor two chats, one on the YouTube and another one on VR community platform. So you may post your questions, comments, reactions, whatever to these both chats. We want to hear from you. We want to see your reactions. I know there are a lot of people who are watching us. So please show us yourself. Show us that you are there and watching us. I think we can dive into the talk. What do you think?
We can. I'm
Okay,
ready.
so please,
Then
so
let's
please
start.
share your screen. And
Um,
yeah, I will ask our operator to show it to all of us. So, guys, yeah, reminder: Instagram photos. Yeah, on Where Community have online activities. Please join them. All 3 days conference will be live. They are there, so you can take part in them anytime. Yeah, can see Ivan's screen. So, Ivan, good luck. Let's go.
Thank you very much. So let's go, guys. Welcome. Thank you very much for coming. I'm really happy that you came today, and I'm happy to be with you. So today's talk is Java compilers. Why is Java a suitable platform for low latency systems? And low latency systems are is a must for example, high frequency trading. And we will speak about like high frequency trading, compilers, and answer the question why Java is suitable platform for that. I will start with myself. Yeah, I'm Ivan. I'm 7 years with EPAM, low latency fun, more than 10 years in IT. I don't have a specific hobby. I'm hobby collector. I'm switching them like every 3 months. I don't know. That depends on the hobby. Here is my Twitch. Sometimes I'm doing streaming. Not lately too much, but sometimes, occasionally I do. And let's go straight to the agenda. So first, we will have some brief overview about like, you've heard a lot about low latency. Yeah, low latency. We will dive deep what it is. Then I will show you example architecture of how high frequency trading low latency systems look like. Then I will show Java platform and tools to support such systems. So I will show how Java actually helps to build this kind of system. And in the end, we will speak about Java compilation because it will be mandatory part, about Java C, about tiered compilation, about metrics with JVM collects, about optimization the compilers do. Let's go. So low latency. I will start with a story because I started my career like 10 years ago, and that time Java was not about the speed. Yeah, very often I've heard that the speed is the problem of Java, actually. Someone was showing benchmark of Python. Of course, C and C++ is out of the question. Java was slower, yeah. And this was my pattern for quite a long time, yeah. We can do amazing enterprise applications in Java, but it's not very suitable for low latency and some very speedy systems, let's say. And I was under this impression until I tried myself to one of the low latency projects. And I had a discussion with one of solution architects here in EPAM. And he told, yeah, of course, Java is like one of the first options to build low latency systems. And I was like, how is that? How is that possible? Java can be slow. Yeah, it's not possible. C and C++ is faster. And he says, come on, Ivan, this was like 10 years ago. You're a dinosaur. You need to read a lot about new things which were added like in recent years to Java. And this is exactly what Roma, what you were asking about, like what is the talk about? The talk is about to prove that Java is very, very good platform for low latency. I would say that one of the first choices. So, first of all, before we will go to definition, I would like to cover what domains actually are suitable and where low latency is definitely required. Yeah, so the one which is like I can say about my experience because I worked in 2 projects related to low latency is financial services. Yeah, so high frequency trading and electronic trading platforms. Currently, they have a really high requirements to the latency. Yeah, so high frequency trading is the trading when the order is opened and closed within a second. So you open the order, 2-3 tips of the price, and you close it. Yeah, so definitely no human interaction. Everything is automatic, algorithmic. Etc. No trader looking at the graphs and taking the decision. And you understand that within a second, the request should go to the platform, to the exchange, should be opened and closed, and everything within 1 second. So yes, we need low latency for that. Second thing, gaming. Everyone likes playing games, and everyone hates lags. Yeah, and like you don't want to throw your mice in the wall when your game is lagging and you lose because of latency. Telecom, yeah, everyone wants good communication, good quality of sound, of video. So telecom is definitely one of them. Now we can combine like automotive, military, space, and aviation all together because they pretty much require this for their autopiloting system. Yeah, so we don't want our Tesla to send REST request and receive some response in case if it detects that another car stopped abruptly and you need to take decision really fast. So low latency is here suitable, especially military, space, aviation, everything here as well. Also, there is one important thing which seldomly is mentioned. High performance computing. So some scientific research is actually space exploration. Yeah, they require very heavy computation. Maybe low latency in general, like latency is not required, but the speed of computing is very important for such huge computation. So this is one more domain. And now go into the definition. What is low latency and actually how low we can go? Low latency refers to the minimal delay or lag in the transmission of data or execution of a process in a system. I will not go to too much details in figures, numbers, graphs, etc. There is an amazing talk by Daniel Shaya, not very fresh, but in this world, even talks from 2013, they are still, in many cases, are relevant. It is called exactly like this. How long can you go? Ultra low latency Java in real world. So if you are interested in like details, you can watch this talk. I will give just a small example from financial world, how we can define low latency. So a lot of exchanges provide such a service for their customers, which is called colocation. It means that the market players put their servers right on the premises of the exchange, near the servers of the exchange. And in USA, there is an official like federal law that if exchange provides such a service, they are obliged to provide equal access to all traders, which means that every trading server should have the same length of fiber to the exchange, because the longer the fiber is, the longer request can go, yeah. And in high frequency trading, low latency is actually when the length of fiber matters. Yeah, so that was amazing for me to know that people could think even about like length of fiber cable, and this can really matter. Next topic, just to give example understanding how architecture of high frequency low latency system looks like. Yeah, so this is exchange. Exchange is clearly like their servers on their side, and they provide the data feed. Yeah, so they provide some data to market players about market, about prices, about orders executed, etc. So it is going to some market data receiver, which is already on the side of the player. Yeah, so some trader. Trader is receiving this market data, and based on some strategies, for example, it can be not a single one. I'm sorry. It can be multiple strategies. They are taking the decision about doing some operation. Yeah, so we decided to buy stocks, or we decided to sell stocks. There is a trigger which is going to order management system, which is later sent to the exchange for execution. Yeah. Sometimes when collocation come into place, there is even can be some super fast strategy with dedicated some transport, which will receive, which will send the orders to the exchange, even without like without applying those, let's say, slower strategies. Yeah, and there is some trade monitoring backend. Yeah, some backend services which we need to keep our system stable, keep our system monitored, etc. So this is like high level overview. Now let's have a look. What do we need to achieve that? It's definitely not a comprehensive list. This is something that I consider like the most important. And the first three items, this is something that you as developers, me as developer, cannot too much influence. Yeah. So first of all, you need fast hardware. Yeah. So this is up to company to buy like amazingly fast computers. Geo proximity. Yeah. So this is collocation, which we were talking about, and this is really important. Even if you are not ready to pay for collocation, it makes sense to place your servers in the nearer to the exchange where you are going to work. If this is London exchange, then somewhere in London. If it's New York, then somewhere in New York. Last but not least, this should be designed before the whole system is built. It's security. In low latency system, you cannot on every request check some tokens or doing some encryption, decryption. This is too slow. So the best possible way to minimize security efforts to build some external perimeter. Yeah, so if you are collocated with Exchange server, then most probably it will be much easier. Yeah, so but this security thing should be thought very much in advance, and it should not be included in the end system, in the end logic, which I just showed on the diagram. Now, something that you can influence, and this is the first of all, code efficiency. Of course, we need your code to use optimal algorithms, to use optimal data structures, etc. Next thing, fast transport. Definitely, we see that the system is very complex. And to have a single monolith could be tricky even for latency reasons, because you will have to do a lot of operations in a single application, which is not very desirable. That's why you most probably will go to some distribution by microservices. And in order to have that, you need to have fast transport. Yeah, so to transfer information from one service to another, and also from Exchange to our servers, and from our servers to the Exchange. Next, very important things is effective work with memory, and we will go in depth with that. It's not only like macro world, it's on macro world and micro world. More details will follow. Effective concurrency. We all know that concurrency is making our applications faster. But to be completely honest, in low latency, concurrency can make your application slower, because you don't think too much when you write concurrent code. You don't think about how much contention you can have on definite resources. Yeah, you cannot predict that, and the concurrency must be very smart in such systems, as well as logging and persistence, because logging and any other input output, yeah, this is very expensive operations, as well as persistence. So those three things, I combined them later in one, but they are very, very important to have this designed really smart. So let's take our favorite Java platform and see how we can build such system using Java tools. And let's start with fast transport. Yeah, so typical enterprise application uses something like REST, Kafka, SOAP, GMS, RMI, TCP, file sharing, whatever, name it. Yeah, but what is it if it is not fast enough? Yeah. Here I wanted to give some joke about UDP protocol, but I was afraid that you might not get it, and this was a joke. So UDP protocol is extensively used in high frequency trading, and this was a huge surprise for me. I knew for sure that UDP protocol is not reliable. Yeah, we cannot guarantee sequence, and we cannot guarantee delivery. And for financial service, which must be 100% precise, this is not acceptable. And I was wondering that UDP is not, we cannot use it. So how do we do that in general? Why have you ever thought why UDP is not reliable? Yeah, so TCP, UDP, pretty much similar things. Why UDP is not reliable? Now let's imagine how UDP works. Yeah, we have two buffers: sender buffer and consumer buffer. Producer buffer writes some data. Consumer buffer recreates the same data on its side. Yeah, so in one place, in another place, we have two copies, and then we read from our buffer. Yeah, what will happen with TCP if you will not read fast enough? Most probably, if you will not read fast enough, TCP will not write because it doesn't receive confirmation that it was read. Yeah, it was read, and TCP will stop writing. And that's the way how TCP guarantees the delivery, the sequence, etc. With UDP, it's like, are you getting? I don't care. Yeah, just send everything. So it's broadcasting. So the smart way to make UDP not fail is read at least at the same speed as the producer writes. But in the very smart systems, your reader will be much faster than the writer. Yeah, and if you will read everything from with the same speed as producer is writing, your UDP will not fail. Yeah, I have seen this. This is something that I have seen on production system, that we didn't have any single case of UDP failures in weeks. And what to do if it still fails? Yeah, so there is no guarantee by documentation, by specification. There are no guarantees. What to do if UDP fails? First of all, the most regular approach, as everywhere, is two UDP buses. Yeah, so if we expect something and we didn't receive it from single bus, we immediately ask the second bus. The second two, I would say that this is a patterns for using UDP protocol. This is sequencer and rewinder. Yeah, so we send the datagrams with sequence number, and on consumer side we are expecting the next number. Yeah, and if we didn't receive it, we either ask the second bus, receive it from there. If it's not there as well, then we enable the rewinder. We are saying, guys, we have missed, like we expected 13 and we received now number 17. So please rewind us data from 13 to 17. Yeah, and we continue reading the data to some buffer while we are rewinding. Yeah, and then processing this rewinded data. So this absence of guarantee is not crucial because there are ways to overcome it. But we already discussed how to make UDP not fail. There are other possible solutions for transport in Java. First two are actually designed, and those are two big frameworks for high-frequency trading systems. They include not only transport, they include also special data structures and special concurrency frameworks to make high-frequency trading really low latency. It's Project Iron and LMAX Disruptor. And they are really used very extensively in many exchanges, in many market players are using them. So you can check in the end. By the way, this is just for the whole presentation. I've collected the list of links if you will be interested in some particular topics. The links to Project Iron and LMAX Disruptor are on this list. So the last slide will be collection of those links. You will see that there. More exotic, I would say, is TIBCO FTL, and this is a commercial solution, so there is no, I guess, free tire. Also fast queues provided by TIBCO. Next, NATCO is something very fresh. And I cannot confirm that it will work, but they declare that they are really fast, and you could read about that. KDB Plus is very interesting framework as well. It is mainly like in-memory storage. It is used for in-memory persistence. Plus, it also provides transport capabilities. So now we see that we have UDP, we have some framework solutions suitable for that, and this problem is covered. Now, second very important problem for low latency systems is effective memory usage. Why it is important? In low latency systems, you cannot allow yourself full garbage collector, because even if you have a very efficient collector, etc., if it will make stop the world for like half a second, you will have a huge problem. Yeah, in one of the projects where I worked in practice, full GC was a production incident. Yeah, it was like we were monitoring the logs of garbage collection, and we definitely knew that garbage collection doesn't trigger. Yeah, if it triggers, it's an incident. And the best way to effectively use memory in Java is avoid GC. Yeah, and for this there is a talk actually by me. I've done it on JDD, I guess, a couple of years ago, about the techniques how to write the code not producing any garbage. The link is available. You can have a look. And what else you can get from that? Actually, you can reduce the overhead of garbage collector, which G1 and those like special like regular garbage collectors have. If you use serial GC, for example, serial GC is single thread, and you know that it is not going to trigger. So you just enable serial GC, or if you are brave and you can enable experimental features, then epsilon can work for you. Yeah, epsilon is like a garbage collector, which is in general doesn't collect any garbage. It just gives you as much as heap as it can, and when it fails, it crashes your application. Yeah, so simple, nice, and suitable for this use case. The next very important thing is avoiding heap resizing. So in low latency systems, you will not see standard, not tuned parameters for initial heap size and maximum heap size. Usually you start with already huge heap. You don't start with a small heap like in regular. If you don't change any settings, yeah, standard Java application will go with like, I don't know, 512 megabytes heap, and once it like goes to filling, it will like increase the size until it reaches the maximum heap size. In our case, the best scenario is minimal heap size is the maximum heap size. Yeah, so if you understand that your application needs 32 gigs, then you start with 32 gigs and never resize it. Later, you will see one more reason why avoiding heap resizing is a very good idea for low latency. The last but not least, with latest JDKs, we received two garbage collectors. Shenandoah, I guess, is still is in like experimental features, but ZGC became production ready starting from Java 15. So in 21, it received upgrade, very significant one. It became generational. So ZGC like declares that it has zero pauses. Yeah, so there is no like not a zero stop the world. In fact, I guess there are micro nanoseconds of stop the world still can happen, but I would not say that it's complete zero, but it's very close to. So other solution for effective memory usage is using specialized garbage collectors. Also, what we can say, ZGC and Shenandoah, those are two available in Oracle JDK, in OpenJDK, but some JVMs, for example, Azul, I know that they have some own garbage collector, M4 or C4, yeah, which is also like declared to be special low pauses, special garbage collectors intended to be used in low latency systems. So at least three points we have mentioned how to effectively use memory on macro world. And now let's go to micro world. Yeah, I guess everyone knows that Java uses processor caches. Yeah, and there are 3 levels of caches: L1 cache, L2 cache, L3 cache. And please have a look at the data. Yeah, so reading from L1 cache is taken usually from 1 to 3 nanoseconds. Reading from L3 cache is like 10, 30 nanoseconds. Reading from like the best possible RAM, it's DDR4. I was looking at like the latest possible RAM. It is written that it's like from 500 to from 50 to 100 nanoseconds. So you see the price of cache misses, right? And that's why you need to effectively use memory on this micro world. Yeah, so you need to utilize those caches very hard. That's why you want to avoid resizing of your heap. Yeah, so once you will have garbage collector triggered, once you have a new memory allocated, all the caches need to be populated or repopulated. Yeah, so all caches can be invalidated. Whatever can happen, yeah, with the caches when you try to reallocate the memory or clean up the memory with garbage collector. And you understand how it will work. Yeah, and now we will speak about one thing which is usually used, warm up. Yeah, so everyone heard that we need to do warm up before our application gets up to the like optimal speed. And usually we say that warm up is about like it does compilation, a lot of methods are compiled, etc. But warm up also speaks about caches. Yeah, so once you do a warm up of your application, a lot of caches are already populated, and you will start reading not from main memory, but from caches once your application is warmed up. That's it about effective memory usage. Let's go further. How to utilize caches, let's say from your code perspective, not from settings perspective. First of all, it's important to use first two points. They are interconnected. Yeah, so the best way to utilize caches is to use cache-friendly data structures. And this is the structures which are sequential in the memory in your JVM. Arrays is very good example. Ring buffer is also a good example. Linked list is awful example. If linked list hash map, for example, this is a not cache-friendly data structure, and you cannot. You will have a lot of cache misses if you will use not sequential access structures. And what is data locality? Even if you have sequential array, for example, it will work perfectly if you will iterate one by one. Yeah, so starting from 0 and ending with length. If you will pick the one like one element from start, then in the middle, then in the end, etc., it can again cause a lot of cache misses. About minimizing memory allocations, we spoke already. Thread affinity. This is like a special topic. It's very hard to achieve, but it can be achieved. And there are special techniques for that. So that you know that something that already started to execute on one thread, it should continue to execute on that thread. Yeah, because wrongly told. Thread which started to be executed on one processor core should continue be processed on the same core. Yeah, so just imagine you have 4 cores and you have 4 threads. Yeah, each of them is executed on the single core. It's all fine. But what if you have 8 threads? Yeah, it's amazing that when shifting of those like scheduling of threads is happening, they are still stick to one single core and not transferred from one to another, because then they will not able to utilize the cache, because the cache is connected with the processor, with the core of the processor. Yeah, and thread affinity is very important part here. Yet it's very, very not easy, not trivial to do. Now about concurrency, logging, and persistence. As I told previously, concurrency should be very smart. Again, the story. Give me a second. When I was interviewed to one of those low latency projects, the interviewer was like out of 60 minutes, 40 minutes, he was speaking, he was asking me about concurrency, and we were like really deep in the topic, and 20 minutes for other topics. On my first working day, he started to show me the system and told all our system is single threaded by design. I was like, why? What is the sense to do it on interview? And he told that on interview, yeah, you person should understand those concepts, but in fact, concurrency must be very smart. Most probably you will not be able to avoid it, because still you need to do logging and persistence. And this is like one of the smart way to use concurrency in low latency systems. Yeah, if your logic is executed in one thread, and logging and persistence are thrown in separate thread. Sometimes I have heard about the systems which even logging and persistence, they just separate to different service. So you just receive the data, do some logic, and push the data to some UDP bus to another service to log it, to like do persistence, etc. Your application doesn't care about of that. Your application cares only about like processing the data and sending the offer order. That's it. Now to the main topic, code efficiency. I guess the developers most interested in this part. Let's speak about compilation. Yeah, so how compilation works in Java, and how you can make your code. Not how you can make, but how Java makes your code. You write code as usual. You don't need to write some special things that to make it compiled in efficient way. JVM will do it for you. And it starts with Java C. I don't consider that Java C is a compiler, because it doesn't do like translation to machine instructions. It translates to bytecode. But a lot of optimizations are done already on this level. But further, we have tiered compilation. There are 4 tiers, and this is how it looks like. The tier 0 is when JVM takes your bytecode and starts to interpret it like standard interpreter stuff. Yeah, then after 150 times, 1,500 times of execution, C1 compiler starts to work, and it takes the it does the fast compilation without profiling. Yeah. Sometimes some code, and JVM analyzes that, it will not go even further. It will not go to any further tier. This is called trivial methods. Yeah, so when the compiler, when JVM sees that the method is very trivial, there is nothing to optimize there. It is good enough to compile it with C1. C1 is like more not primitive, but more simple compiler. There is no sense to throw it to C2, because there is nothing to optimize. Yeah. Then there are 2 tiers of limited profiling. So JVM do some profiling of your methods, and C1 can continue compilation if, for example, C2 queue is full, so C2 is fully occupied, then C1 can continue recompile your code to a more efficient one using the profiling information. Yeah, so limited profiling C1, full profiled C1, and tier 4 is like fully profiled code and fully profiled compilation with C2 compiler. So this was overall picture of how compilation works. And now to optimizations. Even before Java before C1 and C2, like machine instructions, Java C is already doing a lot of stuff for you. So constant folding is quite obvious. Yeah, it's replacing mathematical operations with constants when possible. That code elimination doesn't require any explanation, right? Local variable type inference. Yeah, so var keyword, the new one from Java 10 or Java 9, Java 10, I guess. Now it's resolved on Java C level. Method inlining, yes. So when you have like method call, it's more efficient for Java C to create bytecode so that it considers it as a simple method. So it just inlines your method to the different one instead of using invocation. It will help the efficiency. Constant pool optimizations. Everyone knows about string pool, about int pool, but JVMs usually also maintain other kind of pools which are not that popular, and they are used inside, and they are actually doing the optimization on both memory and efficiency. Control flow optimization. So loop unrolling, simplifying conditional branches, reducing branch instructions. Java C can analyze your if structures, loop structures, and optimize them already on this level. Yeah. String concatenation. Sometimes we do a lot of concatenation. You understand? Yeah, it's the same as constant folding, but with strings. On some JVMs, actually, I guess Hotspot and OpenJDK can OpenJVM, OpenJDK cannot do this, but some JVMs can do tail call optimization. So basically, when you write the recursion, it will optimize this to tail call. The same as Scala do, for example, in their way. So how Java, having like not having the compile in advance, how C or C++ can do, or Graal, for example, ahead of time compiler can do, why Java can be the same fast and sometimes even more efficient than C++ compiled code is because it is watching. Yeah, it's collecting some data during execution, and it can use this data for profiling. So method profiling, how often the method is called. Branch profiling, how this or this if statement is called. Loop profiling, how often the loops are called. Tiered compilation info, what is already compiled, what needs to be recompiled, what doesn't need to be promoted from C1 to C2. This is another topic. Escape analysis, very important if you're still using concurrency. It can do escape analysis and check if the object which you consider guarded, like if you're doing synchronized blocks, if you are doing volatile variables, escape analysis in background, it's all the time watching if this can escape. And if it doesn't, sometimes this was actually very amazing news for me. Sometimes it can allocate the object even on stack instead of the heap. And this helps, again, fighting garbage collection and effective memory usage. Type profiling, I guess it's also not comprehensive list. It's something that I was able to derive, but there can be more. And now coming to like final compiler optimizations, which C1 and C2 do using this information from JVM. The first three lines are about loops. Yeah, compilers can heavily optimize your loops. It can split your loop, bigger loops to more smaller ones, and the other way around. Yeah. So if you have two very similar loops close to one another, they can combine them in one. Branch predictions. This is very important thing, and actually Alexey Shepelov has written a nice article about that. It calculates, for example, you have like if-else statement, and JVM has defined that your if condition is executed like 1,000 times and else condition is executed only once. It can even recompile your code the way that if statement will be closer in the code, in the machine code, than it is in your code structure. Eliminating that code, again, more advanced than JavaC is doing. It's already, again, based on some runtime statistics, on some things which are calculated on the runtime. It can eliminate those things. Escape analysis based optimization. So this is something that I've talked about already. And there are more and more and more. There is really a huge amount of those optimization. Null check elimination, very nice feature. So if someone considers that maybe I shouldn't do null check, most probably we will not get it. JVM will eliminate it anyhow if it's redundant. If it defines that there is already a ready object and it's not null, it will remove it. Huge amount of those. And coming to outcomes. Yeah, so answering our question, is Java suitable for building low latency systems? Fast transport, do we have it? Yes, we do. We have UDP. We have, if we don't want UDP and we want some framework, we have LMAX and we have Iron, TIBCO-FTL. So these solutions are in place. Effective memory usage we've mentioned. Yeah, we have specialized garbage collectors like ZGC, Shenandoah, Epsilon, but we also can utilize techniques not to create garbage and to avoid garbage collection at all. Cache-friendly data structures, there are plenty of them in Java, like built-in, like arrays. Every sequential data structure will be cache-friendly. Ring buffers, which are actually actively used in LMAX, I guess, framework. But LMAX and Iron provides their own cache-friendly data structures as part of their framework. Then we have JavaC optimization. Then we have quick C1 optimizations. And then we have fully profiled C2 optimizations. And this is something like I told in the beginning that Java can be even faster than C and C++. Yeah, why? Because C or Graal, which is like doing ahead of time compilation. So they do compilation once before start, not having this profiled information which we have seen JVM is collecting. In JVM, the process is dynamic. Yeah, so it starts with some basics, and then based on runtime information, it starts to make better and better and better optimizations. And these optimizations, in the end, when you have fully warmed up application and everything is like on the run, it can be even faster than anything you can do on ahead of time compilation. Links collections, as I promised. How low we can go? No garbage techniques. Special talk about Shenandoah by Alexey Shepelov. LMAX disruptor and Project Iron links. For those guys who are in general interested, like me, in low latency topics and low level Java, to absolutely useful resources. Shipilov.net. Alexey Shipilov is the author of Shenandoah. He's a very big contributor to OpenJDK. Also, he's the author of GMH. Yeah, and he's having a huge blog about all those topics. The second is newsletter, Java Performance Tuning, JavaPerformanceTuning.com, from Jack Shirazi. He's doing this newsletter from 2001. So the guy is very, very consistent, and he's really professional and really, really very useful materials. So if you're interested, please review those. With that, I am thanking you for your attention, and Roman.
Yeah, thank you very much. Thank you very much for this great presentation. Thanks a lot. I see we have really hot discussion, I would call it, on the platform. So I hope you can join it after after we let you go. Because yeah, a lot of a lot of different opinions on low latency in Java. So that's really cool. So guys, a reminder, we expect your questions in YouTube and on the platform. And now I pass the voice to Evgeny to ask these questions.
Yes, thank you so much, Roman. Ivan, thank you so much for this great talk. So I will start with some kind of a provocative question, as usual. So let's think about such kind of a thing about low latency. Yeah, so in most cases, that is not a question about how fast we may do something, but how to control the worst case. Yeah, and not to actually fail with something that may take our time. What are the options to control this kind of the borderline and not to prevent it for the low latency applications?
I would say that for low latency, it's actually very much about not only outliers. Yeah, so the baseline is very important because again, when we were speaking about UDP, yeah, if your reader is slow and slow even not for a single case but in general, yeah, you can start losing this data. Once you enable this rewinder, you are again like missing this. But when the outlier happens, this is definitely an incident. Yeah, and when outlier usually happens in the situation when you had for example, GC, when you had Stop the World, or you had some, again, this sequencer rewinder thingy is the reason for such outliers. Because outliers usually when the system is working, they are not happening. Yeah, they are happening during some, like, the system was busy with something. Yeah, and you need, definitely every outlier should be investigated. Yeah, if you've noticed, if someone reported, or however your monitoring is working, every such case should be investigated in the rest, because if it happens very often, high frequency trading systems are based on the fact that they are working all the time. Once you missed 1 hour, you've missed money. Yeah, so that's a problem. And the best way to address such outliers, so usually you don't have them, but once you have them, you definitely find out the root cause. It's not something that we can allow to let go. Sometimes we can. I have seen that. Okay, it happens like once in a week, 3 users are affected. We don't want to spend resources on that. In such kind of systems, we are not allowed in that.
Yeah, yes, thank you so much. Let's move on to another question. In your talk, you also covered the topic that is related to the network protocols, yeah, UDP and TCP. Today, we are hearing a lot about HTTP3, which is based on the QUIC protocol, and may QUIC be interesting in terms of the low latency applications?
To be honest, I cannot answer for now. I haven't reviewed HTTP3 for now yet. I still HTTP3 doesn't provide transport itself, right? It's not a transport protocol. You still need to have some transport under the hood, and for such low latency systems, you don't need higher level. You work directly with transport protocols. Because I was wondering why you would need HTTP 3 or in general HTTP 1 or 2 for such kind of systems. Yeah, you don't need to have a front end, as I told. So those systems are not like manual decision making. Yeah, and in those cases we are working directly with transport, and I guess it's worth looking at. Yeah, I didn't look at it yet, and I'm wondering how to apply HTTP in general to low latency, and can't find the good solution for that.
Okay. Okay, yeah, got it. Let's move on. Another topic that is very hot in terms of the enterprise world or application world, it is reactive and reactive frameworks. The usage like RSocket or R2 DBC or something like that. So are these frameworks interesting in the low latency? Because reactive seems like a possible marketing promotion as a being very fast, very sufficient for any kind of applications. But what is the reality regarding it?
Reality in my for example, in one of my projects was the following: no frameworks. We had JUnit, and this was the only framework, the only external dependency we had. The reason for that is not that we don't trust that they can be fast. They can be fast. We want to have the full control of what is working with the memory. Yeah. So if the framework is fast, extremely fast, yeah, it can be really fast, but it creates garbage under the hood. We cannot allow that. Yeah. And using the framework, first of all, we will need then to investigate a lot on the side of like those kind of things, not only the speed, yeah, not only the latency they provide. This is only one factor, but another factor is how much garbage does it create. For example, this is something that come into my mind, and if it does, we cannot allow that, because we want to have a full control. For example, when I was talking about LMAX and Aaron, they were intentionally designed for high frequency trading, and they don't. So they create garbage. I mean, they don't create garbage, and they are intentionally like they can be used out of the box without this additional check, I would say. Some of market players will not agree with me and will say that no, we will write still our own custom solution. We want to have like full control. That's why answering like directly the question, reactive frameworks are good and useful, but most probably those will be reactive frameworks, because the idea of reactive, the whole low latency system is by design reactive. Yeah, so it reacts on the external event from market data which is coming in, but most probably those reactive frameworks will be self-made. Yeah, so I doubt that someone will take I don't know, Akka in their project, because what is going on inside there, we don't know. Yeah, and we cannot predict.
Okay. And yeah. Roman,
Yeah, I assume that's it for questions. So thanks a lot, Ivan, for great presentation. Yeah, there are a lot of comments that super great presentation. Thank you very much. I hope you can join the discussion in we are community platform in the chat. So guys, if you want to dive into the discussion about low latency with Ivan in our our other participants, feel free to join them in the chat. A reminder, link to the platform is in the description. Also in YouTube chat, there is also some questions and discussion. So do that. Send us some smiles, send us your reaction. So Ivan, thank you very much for your talk, for being with us on this conference. Thank you.
Thank you for inviting me, and thank you all the audience for coming and for listening. I really appreciate that.
Thank you. So now you may join the audience. Thank you. Have a good evening.
Thank
Bye.
you. Bye.